Hello and welcome to Teen Academy. Today we are doing question 9, where we're given a circle with the equation x squared plus y squared is equal to 9, which has the center 0, 0, and the radius, a radius of 3. Now a triangle is inscribed in the circle, and the triangle is PQR, which has the vertices P, Q, and R, which are given, and where Q and R are variable points in the first and the fourth quadrants respectively. Now, for the first question, we're asked to show that y is equal to the root of 9 minus x squared for point Q. So we can show this by rearranging the equation for our circle. So x squared plus y squared equals to 9. We can isolate for y squared, or y, so that y squared is equal to 9 minus x squared, and just take the root of our right side so that y is indeed equal to the square root of 9 minus x squared. Now for question B, we're asked to find an expression for area, for the area of the triangle PQR in terms of x. So to do this, we first write out the equation for the area of a triangle, where the area is equal to 1/2 base times height, where our base b is equal to 2y, since there are two lengths of y that run in this circle, and we know that y is equal to the square root of 9 minus x squared, so it's just 2 times the root of 9 minus x squared. Now our height is equal to some value x plus the distance on the left side of the leftmost quadrants, where the distance is 3. So our height, we can say, is x plus 3. So if we substitute these two values into our equation, we get that the area is equal to 1/2 times 2 root 9 minus x squared, times x plus 3, and then we can cancel out our 2's and get our expression for area. Now, for our next question, we are asked to show that the derivative of area with respect to x is equal to this expression. So now that we've found area, we will differentiate the equation. So to do this, we have to use the product rule, whereby the derivative of two multiplying terms that are containing x is equal to the derivative of the first term multiplied by the second term plus the first term multiplied by the derivative of the second. So if we write this kind of simply, it should look something like this, where we take the derivative of root 9 minus x squared and multiply it by x plus 3, plus our term 9 minus x squared multiplied by the derivative of x plus 3. So if we differentiate, we will find that we get negative x over root 9 minus x squared times x plus 3 plus root 9 minus x squared multiplied by 1. We can then multiply our second term by root 9 minus x squared over root 9 minus x squared, which is just 1, so that we can have a common denominator and bring our two terms together, where we'll find that we get 9 minus x squared minus 3x over root 9 minus x squared, which we can then see is equal to that term that we were looking for. So we have demonstrated this. Now for question D, we are asked to find the y coordinate of R such that our area is at its maximum. So now on to our next question, D. So we're asked to find the y coordinate of R such that A is the maxima. So we know that maxima for any function means that the rate of change should equal 0. So that means we can look at our derivative equation, the completely simplified form, and say that we want to evaluate the numerator. Okay, and find our x-intercepts, our roots, our critical x points. So if we rewrite our equation in quadratic form, we can see that we have negative 2x squared minus 3x plus 9. Now, you can evaluate this by using the quadratic formula, I believe. It's supposed to be b plus or minus. Yeah. You can use the quadratic formula, but I will be factoring this instead, as it's a bit faster. So we need a term that adds up to b, where b is the term in front of our x that's raised to the power of 1, a is our coefficient for our x squared, and c is our constant. So we need a term that adds to negative 3 and multiplies to negative 18, which is our a times c term, negative 2 times 9. And these two terms could be negative 6 and 3, because the sum of them is negative 3. And the product of the two is negative 18. So if we rewrite our expression so that our b term, our x term, is rewritten in terms of our two new numbers, we get negative 2x squared minus 6x plus 3x plus 9. And then we can group these based on similar numbers, values, and as well as terms, x values, so that we get negative 2x multiplied by x plus 3 times x plus 3. And we can group these further so that we have our factored form, which will be negative 2x plus 3 times x plus 3. And we can factor out our negative value so that we have 2x minus 3 times x plus 3. So now we know that our critical x values are x is equal to 3 and x is equal to 3 over 2. And you should get the same thing by evaluating it in quadratic form. So now that we have our x values, we just have to plug these into our equation, our y equation, which is y is equal to 9 minus x squared, which is the same as evaluating it for negative 9 minus x squared. Okay, so we will substitute our x values into these equations into one of these equations to find our corresponding y values and our critical points. So now that we do our substitution, note that there was a minor correction. As from our factored form, we would gather that x plus 3 means that our root or critical x value would be negative 3. So then substituting into our equation, for x is equal to negative 3, we have y is equal to plus or minus root 9 minus negative 3 squared, which is just 0. So we say our critical point is negative 3 and 0. And then for x is equal to 3 over 2, we have y is equal to plus or minus the square root of 9 minus 3 over 2 squared, which is just plus or minus root 27 over 4. So then our two critical points where a would be at its maximum are negative 3 and 0, and 3 over 2 and plus or minus root 27 over 4. And that is all for this question.